Chemical kinetics assignment number 7. If you learn all this, your JE job will be easy, NEET job will be easy, right? Advanced purpose we need to work more, but for that also you have to complete all this. Collision theory questions. To increase the rate of a chemical reaction, the activation energy must be less, because it is the reactant's energy, it is the product's energy, and this is activated complex, it is known as activation energy. If the activation energy is less, for example, second case, if the activation energy is less, then here the possibility of converting into products will be more. So decrease in activation energy is good. But activation energy depends only on the nature of reactants, right? That is your next question. The energy of activation of a reaction is dependent on only nature of reactants. Activation energy is not depending on concentration or pressure or temperature. Okay, now for a reaction, activation energy is fixed. If the activation energy of both forward and backward reactions are equal, okay, now means if this is equal, then delta H of the reaction is going to be 0. There is no delta H. See, in this is delta H. For example, you are taking like this, I will be giving you a bigger here. So this is delta H. But this is activation energy for forward, this is activation energy for backward. If it is a reversible reaction, or if you want to see, this is exothermic change. For endothermic reaction, this is delta H. But if both forward and backward both are same, means there is no delta H. Delta H is going to be 0. For the exothermic reaction, A plus B gives rise to C plus D. See this one, exothermic reaction. Delta H is the heat of reaction, this is delta H. And EA is the activation energy, this is the EA, activation energy. Then the activation energy for the formation of A plus B. For the formation of A plus B means he is asking backward reaction. So this is the backward reaction. For backward reaction, that is nothing but EA plus delta H. This part is EA, this part is delta H. So this part is going to be EA and delta H. EA and delta H. The rate constant K1 of one reaction is found to be double than the rate constant of K2 of another reaction. Rate constant of K1 is a double, means the rate is very fast. When the rate is very fast, activation energy is very less. So when K1 is greater than K2, double that of the rate constant K2, that means E1 is less than of E2. Simple logic. When rate is more, activation energy is less. When rate is more, activation energy is less. When rate is more, activation energy is less. Collision theory is applicable to bimolecular reactions. It's a simple postulate. The rate constant is given by the equation K is equals to PZE minus EA by RT. Generally we say rate. Okay, now otherwise rate constant we write generally AE to the power of minus EA by RT. Which factor should register a decrease for the reaction to proceed more rapidly? Activation energy should decrease. Okay, now temperature Z and P are not related to decrease. Okay, now because it is probability factor, it is frequency of collisions, and this is temperature. They must be more and EA must be less for the rapid reaction. Threshold energy. What is threshold energy? Okay, now for example, this is the energy of the reactants and this is the activation energy. So threshold energy is equals to energy of activation plus reactants energy. Reactants energy plus activation energy sum is known as threshold energy. So threshold energy is equals to internal energy plus activation energy. Arrhenius equation, the fraction of effective collisions is given by E to the power minus EA by RT. Direct statement it is. The threshold energy of a chemical reaction depends only on nature of reactants, because threshold energy is sum of the activation energy. Activation energy depends only on nature of reactants, and it is threshold energy is the sum of the internal energy. Internal energy is again nature of reacting species, only on nature of reacting species. Thank you.